Hello and welcome to Eyes on Research, the podcast that digests the latest scientific innovations in eye research using simple and understandable terms. I am your host, Thales Guimarães, medical doctor and clinician scientist at Moorfields Eye Hospital. Welcome to the first episode of this podcast. I hope you enjoy and have as much fun as we will. Today, we're talking about a very hot topic: artificial intelligence, in short, AI, in ophthalmology. Here with me today, I have the great pleasure to introduce you to one of the leaders in the field, Dr. Nikolas Pontikos. Dr. Pontikos is a group leader at the UCL Institute of Ophthalmology and the deputy director of the Moorfields Eye Hospital Reading Center in the Clinical Artificial Intelligence Lab. His team research focuses on AI and machine learning applied to analyzing genetic and imaging data for eye disease to diagnose and prognose disease more accurately and efficiently. So, Nicholas, thank you very much for being here with me today.
Thank you, Thales. It's a pleasure.
I hope I got that introduction right.
Yeah, that's all good.
Right. So recently, we have been hearing a lot about artificial intelligence. It has become a very hot topic. And also machine learning, be it in the internet, in the journals, in magazines, or TV shows, right? It's all over the place. So some people may associate these terms with, the Google kind of like machine learning tools, while others, such as myself, immediately think of the Terminator movies and John Connor. So my question to you is, generally speaking, when we hear about artificial intelligence and machine learning, what exactly are people referring to?
Great. Firstly, yeah, thanks, Thales, for having me on the program. So I think you and Google and everyone, you're all using AI and machine learning, or thinking about AI and machine learning, but in different ways. It is a very broad area. If I was to try and summarize it very simplistically, I would say it's the application of computers to learning from data in order to make predictions. Now, these predictions can be predictions applied to, for example, diagnosing diseases in the case of ophthalmology, or can be predictions, for example, about predicting the price of a house, the price of a particular item or stock in the financial markets. They can also be predicting what are you going to type next when you're typing into your Google search bar, for example. So it's a really broad, the applications are very broad, but at the end, it all boils down to machines learning from data.
Okay, that's very interesting. Really makes me think about how promising the applicability of AI in the field of ocular research is. And speaking of which, when I look at the fascinating work that your lab has been producing over the years, I see projects that range from things that essentially belong to the field of language AI, is my understanding, such as, for example, extracting genetic information from clinical notes, which is very interesting. But it goes all the way through the detection of early disease and decision support systems for clinicians who are actually seeing patients in a day-to-day routine. So, in your opinion, and that may be a hard question, but what is the role of AI in ophthalmology?
Uh, so AI in ophthalmology has been mostly used on imaging to analyze imaging data, as you're aware of as well, Talis, from your work. So automating the analysis of images, in particular, for example, the prediction of what a disease is from an image. So trying to automatically identify a type of disease from an image. This is known as a classification type problem, but also identifying pixels in an image. So what area of an image uh, is the disease is the lesion or more, the diseased area of the image. So the area of the image that is abnormal, where there's, for example, some sort of vessels, blood vessels, which are leaking, for example, or where there's some abnormality in the image. So that's known as image segmentation, and that's another very broad application AI to ophthalmology in imaging. And then there's all kinds of other applications. You alluded to processing text automatically. So a big problem in the medical field is that historically a lot of the letters have been written by people, doctors, for example, in free text format, which means using natural language, so like English, for example.
And
And
also with a handwriting that no one understands.
and exactly, that's another problem in itself. But yeah, I'm talking just about the typed letters for now. So even the typed
Hmm.
letters are problematic because there's different ways of writing the same thing, and the natural language is quite ambiguous. And so extracting, for example, information from those letters in a consistent way in order to be able to meaningfully compare patients' diagnosis or identify patients with similar diseases or symptoms or genetic causes of their disease, for example, that is very challenging when the letters are written in this natural language free text way. So being able to automate this with the extraction of information from these letters, known as natural language processing, that's a really important topic as well. Yeah, so that's a very active area as well. And
Yeah, that sounds fantastic.
and the specifically the example you pointed of the recognizing handwritten text, that's in itself again another problem because that requires recognition of the characters that have been written in the text. So that's known as optical character recognition. And I'm not dealing with that myself, but that's another can of worms in to
Yeah.
deal with that sort of data. But yeah.
Yeah, it all sounds fantastic. And looking at everything that, all the projects that you have and the grants that you have, if I had to pick one to discuss today, of course, it would be I2G. That's the one that strikes everybody's curiosity because it's such a big project, and it has the potential to really modify the field of genetics. So, can you tell us a little bit more about I2Gene and what it is?
Yeah, so i2Gene is an AI project. The goal of i2Gene is to take as input images from the retina of patients who have a suspected type of disease and to be able to accurately identify what is the gene that is dysfunctional in this patient and causing their disease. So that's kind of the high level view of what I2Gene is. Um, so I described earlier the different types of AI systems when that work on images. I mentioned there was classification problems and segmentation problems. What I'm describing at the moment is a classification problem. So that's what I2Gene is doing. Just to give you a bit more background on the types of diseases I2Gene is working on. So these diseases are called inherited retinal diseases, and they are, as the name suggests, inherited from parents, from a person's parents, and they can be either inherited from both parents or from one parent, or just from the father or the mother, depending on the type of disease. And they are genetic. So you inherit your genetic, your DNA basically from your mother and your father. And what these people have is they have usually a gene which is not working as it should. And this is caused by some inherited genetic cause. Um, and they can present with very uh, different types of diseases depending on what gene is affected. Now, clinicians who have been trained in this area are able to look at these images and quite accurately identify what is the type of disease. How it is, these diseases, they are quite rare diseases, and so there are very few people who are trained to look at these images. I mean, your research tell us, and the people you work with, they are one of the only very few groups, I would say, in the world that can really specialize in this. And so it's really this skill is basically quite rare. And so if we can develop an AI system that can use this that can do this, we have essentially a computer, the equivalent of a human expert, a computer expert that can provide this service to a much wider community of people than is currently possible.
Absolutely, Nicholas, and you hit the nail in the head there. It's actually a very niche area, and only a few people are doing this. So, just for our audience, there are more than well, we say 300 genes that have been associated with some form of retinal disease that is inherited, as Nicholas well put. So, it can be inherited in different manners, but basically, it means it passes from generation to generation in different ways. So mutations in one of these genes can cause what we call an inherited retinal dystrophy, which is basically an umbrella term because it encompasses all of these different diseases. So, as Nico said, because the features of different retinal dystrophies they frequently overlap, it's very hard to make that diagnosis accurately, particularly if a patient is unlucky and is not geographically located near to one of these places that Dr. Pontikos was telling, multi-specialty eye hospitals or hospitals that offers this kind of very specialized and niche service. So what Dr. Pontikos just told us may be a complete game changer to the entire field of ocular genetics, at least in terms of increasing the accuracy of genetic tests. That's very promising, Nicholas. Um, as a final question, what do you think is the future of AI in ophthalmology, Nicholas? And are machines taking over? And perhaps more important than that, am I still going to have a job by then?
You will definitely have a job, but it's good you're diversifying already and thinking about podcasting. uh, but no, they will. Yes, you will.
Thinking of all my alternatives in case they just take over. I've watched a lot about the Terminator movies, John Connor, and those things. So yeah, I'm
you
just preparing.
you'll definitely have a job. I think everyone's job is going to be different, including my job. With, for example, ChatGPT, like so, computer programmers will also have a different type of job. I think one thing, I think one way of thinking in computer science is that you're always trying to make yourself redundant in the sense that you're always writing. If somebody asks you to do something, you write a computer program to automate it, so you don't have to do it again, right? And so this is pushing you to evolve constantly and change what you do over time. So in the same way, we are trying to automate a lot of the things that are currently being done manually. That's definitely the way we are going, and we're hoping that as we automate more things, we can think of sort of bigger problems, more high level problems, and we can spend more time, especially for doctors, can spend more time talking to people and managing patients rather than just analyzing images, for example. So giving time is the one thing we don't have, all of us are always after we don't have. So we're
Absolutely.
hoping these AI tools, they're going to give us more time back. That's what we're hoping.
And absolutely, it looks great. And do you think this will be inbuilt in the diagnostic tools? Is that where you think we're going?
Yes, well, definitely that's where we want to go. We do have to be very careful though, because obviously, you know, these AI tools, like humans, are not uh, can make mistakes, right? So then they're not
Mhm.
free of errors, and whether the error comes from whether it's a human telling you something or it's a computer telling something, you still need to be careful about checking that data. So there's a real problem that we need to be aware of, which is sort of an automation bias problem, where the people that are using these tools are basically know less about the area, and so might think that the computer is always right. And when the computer is wrong, they might not have the knowledge to see that the computer is wrong. In the same way that if you don't know much about an area and you ask somebody about something, they tell you something, you're going to think that's true, right?
Right.
just
Yeah.
because you don't have the knowledge to be able to assess whether that person is telling the truth or not.
Yeah.
So what would you as a human do, I guess, to try and find out if it's true or not? We need to think about that as well for AI, right? So explaining, for example, the explainability of the steps that have been taken in order to reach a decision or a prediction in the case of an AI system. So explainability, I think, is going to be very important. And we're going to want to make sure that the AI is using the right information in the right way, that is not biased in some way, which it can easily be, especially based on the data sets that we're using at the moment to train the AI system. We know about this hidden bias that
Right.
so we just need to be very aware of this. But definitely, I think the optimist in me saying uh, we're heading in the right direction, and we're all contributing to this with our research in making things more efficient, automatic, and democratized in the sense that we're making a service only available in a few geographic areas, as you very rightfully said, Thales. We're making it more widely available. So that's the goal.
Yeah. That's hopefully we'll get there soon.
Yeah.
Uh, well, thank you for your amazing work, Nicholas, and I'm looking forward to hearing more. And thank you very much for your participation in this episode.
Thank you very much, Thales. A pleasure to be on your podcast.
Thank you. And to our audience, I'll see you in the next episode.